Hey guys, we're Team 3. I'm Ben Kai, and I was the advisory system.
I'm Chang, I'm the control system.
I'm Yihan, and I'm the sensor pick.
I'm Evo Xu. I'm the motor guy.
So for our project this semester, our objective was to create a rover that could traverse the course shown here. We would start at one end and go down one lane, up the other, and then back down towards the end. Throughout the course, there would be ramps that would be randomly placed. This is just showing how big the ramps are compared to the rest of the course. And we would have to record where the ramps are in the course and then send that information to an advisory system along with the sensor data and the motor distance traveled, and show what ramps were in the course. And then for the design of the rover, the general setup is as follows. The green box outlines what is on the actual rover. There's a control pick, which controls communication between the advisory system and the other two picks for sensors and motors. The sensor pick ran 2 ultrasonic sensors, which helped us determine where we are in the course. The motors were pretty obvious. They helped the rover move around the course, and they had certain commands they ran, such as the U-turn at the end of the course, moving forward and small 5-degree corrections to make sure it was lined up parallel to the wall. And then all that information, the motor distance and the sensor values and the state that the rover was in the course would be sent through the control pick to the advisory system, and the advisory system would plot all that information and record where the ramps are.
Alright, so that's what it likes inside the rover. There are 2 batteries here. One battery is used to power the sensor picks, the control pick, and the sensors. And the other one is used to power the saber-tooth motor controller and my motor pick. The motor controller is used to control the motors. I'll communicate with the motor controller through UART and send commands to it. And I also receive feedbacks from the shaft encoders, which are these 2. Shaft encoders are connected to the level shifter here, so that it can shift the signal from 5 volt to 3.3 volt, and then it will connect to my motor pick. I'll receive command from the control pick and then carry out the commands. The commands will be left U-turn, right U-turn, go straight forward certain distance, and reverse certain distance. And there are small adjustments, which is about 5 degrees.
Well, for sensor pick, there are 3 main job it has to do. It first responsible for sensor reading, sorting, and calibrating. Then it also responsible for select a certain state based on the sorted data, and it also responsible for store the data in the master queue and provide it to the control pick if control pick requests data. So the basic flow of how sensor work is it first started, and when it started, it immediately calibrate the accelerometer, and it will take the first reading as a reading is assume it's going to be the ground level voltage, and whatever future reading will be compared to the initial voltage. If the difference is certain as a certain degree, certain voltage, it will assume it's either up the ramp or down the ramp based on the certain reading. Then it will read. Then the pick is reading all 3 sensors. Each sensor will take 5 readings, and after the 15th reading is done, it will sort each sensor vector, based on the using bubble sort. So the sensor will, after the sorting data, the sensor will be range from minimum to max. And since there's only five sensor data, we assume the third one is going to be the most accurate sensor reading. This way limits the lower if there's a low peak or high peak problem. And based on the sensor reading data, it will go through a comprehensive state machine. It will look at it will first look at the values of each sensor, especially the left and right sensor. Actually, it will first look at the accelerometer reading first. If it sees a run, it will automatically goes looking at the previous state of the sensor. If it's after run, if the sensor is in the right side before entering the run, then it will assume that it's in the right side and it's after run. If the same thing applies to down the run. Then if the rover is not on the run, then it will look through previous state and the values it get and determine the corresponding state going to be. And after the state is determined, it will store in the message queue. This message queue is not the same message queue as the original framework. It is revised to be only capable of storing only one message at a time. And it also, the original message queue also stop storing if the message queue reaches to full capacity. The revised message queue, the new message will override whatever the old message is, so that the sensor data will be accurate to the time when the control pick read it. So after the message is stored in the message queue, it will restart reading sensor data again and continue repeating the process until the rover is stopped.
The control system is responsible for two major tasks. One is data transmission throughout the whole system, and one is for a self-autonomous control algorithm that controls the rover while it's in the course. For the data transmission, there are three important parts. The control pick uses USAR transmission protocol to communicate with the value system through a Wi-Fi connection, and it's set to a low priority interrupt that receives user input commands and outputs data collected from motor and sensor for supervisory plotting and so on. And it also uses fast I2C high priority interrupt transmission protocol to collect sensor and motor data, and also it outputs the motor command through the I2C. And it also uses a timer which is set to 1/10 second polling to trigger data collection and redistribution for of every 1/10 of a second. All this ensures a very fast data transmission throughout the whole system, which allows not only the accurate data plotting and also accurate rover control, which is next. The control algorithm is basically first the whole control algorithm is triggered by the user input saying the rover should start traversing the course autonomously, and once the user triggers the autonomous control, the rover will, based on the timer trigger, will first pull the data from the sensor and motor and parse the data for processing, and then it goes to compare the current state and the previous state, and to understand where exactly the motor is right now and what action should be taken. And then next it goes on checking if the rover is off course or it is on course, and based on the data from the sensor, and see how much correction it should make. And then after the decisions has been made, the control pick will go through the I2C transmission to transmit the command to the rover, and use the I2 and Wi-Fi connection to transmit the data to the supervisor system.
For the advisory system, I was in charge of receiving data from the control pick and plotting, and also being able to send commands back to the control pick to stop and start the actual navigation of the course. So the basic structure of the control system was all done in MATLAB through the use of Wi-Fi. So the data was received over Wi-Fi and connected to a serial port here. In MATLAB, the received message would then be directly sent into a data storage system that was created from scratch. And then completely separate from that system was a 1-second timer that would update the GUI. And that was because I didn't want the updating of the GUI to interfere with any message reception, which would possibly result in loss of data over Wi-Fi. The GUI had 3 main elements. The first being a map showing where the rover was on the course. That was based on sensor data and motor encoder data received from the control pick. Then there were plots of the sensors, the actual distances that the sensors were reading between the walls of the course, and the accelerometer data, which showed the tilt and where the ramps were on the actual map. Then the third part was control buttons. Those buttons would be able to control the rover in sending a message over Wi-Fi to the control pick. Mainly that was used to start and stop the rover at the beginning and end of the course, but in the case where the rover needed manual navigation, it could move forward X number of centimeters, reverse X number of centimeters, make a right and left U-turn.
看到这个都激动人心。完蛋！哎，
它是因为它那个管太近了。
No worries，我当时发现那种非常高级了，你就看了 C 没 C 就知道我的选择权有多么的认真啊。